So in the spirit of solidarity with the writers striking in Hollywood, I tried to use GPT to write a script for this video to see like how good of a job it could do, and it's fucking terrible. I'm sorry to say, it's just so stilted and like the humor is so forced. It does not. I can't be doing it. Maybe GPT-4 is better, but I want 3.5 because I'm not paying for it and it sucks ass. So anyway, this is me, authentic, off the top, no script. I couldn't be bothered writing one for myself. But today we're going to do a code with me. I'm not going to say it's a tutorial per se, but it's a code with me where I'll be working through something I think is an interesting problem and trying to sort of explain my thought process, explain my workflow, explain how I get this done sort of fairly efficiently. This is a personal pride point for me, as I characterize myself as an efficient worker for things like this. So yeah, explaining some of the skills that I've learned both professionally as an analyst and also as a hobbyist programmer, tips and tricks, that sort of thing. And what we're going to do is find the objectively optimal starter champion in LoLdle. Now, LoLdle, for those of you who don't know, is a Wordle clone where instead of guessing 5-letter words, you guess League of Legends champions. If you don't know what League of Legends is, then I'm happy for you. If you don't know what Wordle is, you've been living under a rock. And today what we're going to do is figure out with Python and some maths which champion, as a starter guess, gets you to the right answer and the fewest number of guesses in the long run. Okay, so I'm going to start off this video by playing today's LoLdle. I'll probably edit this down because I'm quite bad at it. And I'm going to start off guessing Varus, which incidentally is recommended by some random website as the best starter guess. More on that later. So immediately I can see I've got quite a lot of information because male comes up in red. I know the champion I'm guessing is female. I know they are neither an ADC nor a mid laner. I know they have some overlap with the species Darkin and Human. I know they use mana, but they're melee. They're not from any of these regions and they're released since 2012. So what's that? A female, mana, melee, Darkin or Human. It's probably Human, it's not many Darkin. Could be a support. So let's guess Seraphine. Oh fuck, she's melee, I'm stupid. Okay, but she's not a support. Right, and before 2020, so we've got probably a top laner. Let's try Alawi. Did I get it? I got it in 3. Okay, that's a really good game for me. I'm so pleased with that. That's going right in the video. I'll release this obviously after this day has ended, so this isn't a spoiler. Okay, so first efficiency tip is planning ahead. There are certain elements of your plan for your project that you know you're going to have to do no matter what. There's no way that they change. So one of those for this project is I'll need some way to replicate the data set that gives all of the champions their characteristics. It doesn't matter what I'm going to do after that, I have to do that step. So I can start doing that right away and be thinking about what comes next whilst I'm doing it, sort of parallelize the thinking on that one. So what you're seeing here in the background is me figuring out how to do that. So if you go to the LoLdle website, you'll see that it says it's collected from a mix of the Riot API and some fandom Wikipedia pages. And I think, oh man, I'm going to have to collect all of that data myself to make sure that it matches up. And I realized, no, of course I don't, because all of the LoLdle data can be accessed through the LoLdle website. All I have to do is guess every champion in the game incorrectly, and then run a web scraping tool over the displayed results of that page, and that will get me my data set. And I can do that really quickly and really efficiently because I already know how to do that. I've done this sort of task a bunch of times before. So that's, I guess, a little productivity hint is if there's a way that you know to do something, just do it. Like, don't try and get too fancy. Don't overcomplicate and reinvent the wheel. So the code that I'm showing and the sort of interacting with the HTML that's going on in the video here is me writing that web script tool. So I'll talk through how I set these up, and I'll try and pause the video at sort of points to show off each of the code. So essentially it's just a very, very basic script. It's you initialize an array, you add arrays to that array to end up with a list of lists, you convert that into a data frame, and save that to a CSV. It's a very simple, replicable, easy to set up workflow. You'll also notice I'm using GitHub Copilot here, so you'll see bits of code sort of popping up as suggestions and me just accepting them and moving on. GitHub Copilot, fantastic tool. Honestly, don't remember how I used the program without it. It will save you 30 or 40% of the time. There's nothing but praise for that tool. The other tool you'll see me using is obviously ChatGPT, all the rage right now, but genuinely just so helpful for writing out all the sort of syntax that you can't be bothered thinking of, giving you the sort of broad structure. I often come here if I'm having issues or I can't remember how a particular function is supposed to be written, and it will just do all that sort of boilerplate stuff for me at length, and that saves me huge amounts of time. So again, in 2023, you've got to be learning how to use these sorts of tools to increase your productivity. It's definitely a case of it's here to stay. Adapt or be left behind. So that's my sort of workflow with this, is just request certain snippets of code that I know I'm going to need, have it generate them for me, and then I'm still the one implementing them. I guess it's a hybrid workflow, I guess you could call it. But yeah, so create a list, add rows to the list, convert it to a data frame, save it to CSV. That's all you have to do, that's the data set. And I'm going to be using the Selenium library for web scraping. So the way that this works is it creates an instance of your favorite browser, using Google Chrome here, and allows you to interact with HTML elements on that page. So the script, all I have to do is identify the boxes containing the champion's attributes, which I'm showing you here, figure out what their HTML tag or class is, and then iterate over that. Selenium provides the ability to access all of these elements as an array, an iterable array in Python. So you iterate over these and you extract the information, the element.text method, create a row with each of the attributes in order. The order's nice and predictable because it's a table on the screen. Enter that into the data frame, save it, and you're done. I also figured out here, as a time-saving thing, that I could just manually mash all the champions, because I was thinking originally I would have to create a script that would automate typing in each champion's name in order and ensuring that the champion of the day, which at the time was Katarina, happened last. And then I realized actually I can just spam A enter, B enter, C enter, so on. As long as I don't hit K for Katarina, I can guess all the champs myself in 30 seconds. That's what you're looking at now. Or maybe a minute, rather than spending 15 writing Python code to automate it. So that's another lesson, I suppose, is you don't always have to automate. Sometimes manual procedures are actually really efficient if they're one time. In this case, I made a mistake in my code and I didn't get the names, and I also missed about 10 champions, so I did have to do it twice. But even doing it twice, I think, was faster than the development time of writing that functionality into the scraper. So you'll see here, coming up with the completed LoLdle.csv file, which contains all of the champions, all of their attributes, and this whole process has taken me probably less than 30 minutes because this is just such a simple, sort of repeatable method that I like to use. So I'm pretty pleased with the timing, I suppose, the pacing of the project so far. But now it's time to talk about next steps. Okay, so once again, rolling with I can start working on things that I know need to happen while I think about things that can be different later. So I'm going to start a new Python file, call it solver, do the classic import pandas, numpy, and matplotlib. I actually don't have matplotlib, so I end up removing that. I read in that CSV of all the champions, remove the axis column, and then I know I'm going to need to do some data processing, so some of those champions with multiple attributes, like jungle, comma, middle, or human / magically altered, whatever, I'm going to need to split those out into arrays so I can compare against them as arrays, which is what they really are, not strings containing commas. df.explode is not a real function. GitHub Copilot lied to me on that one. Or at least I couldn't get it to work. It might be in a different version of pandas. So I'm figuring out which columns I'm going to need to do this for. I'm looking at the Excel data. Excel, fantastic tool. People often clown on it for being, I don't know, boring or basic, but actually a fantastic tool. Really, really versatile. You can do a lot with Excel, so I recommend getting very fluent with Excel if you're looking to do any sort of analysis, data work, that kind of thing. So here, I'm applying a function row-wise, that's the axis equals 1 keyword argument, to this data frame to process the attributes into lists. So that'll be the first step. Def.apply method is the way that you usually want to interact with data frames. It's a lot faster. It sort of parallelizes the operation across potentially quite long data frame axes. In this case, I'm going to run it once for each column of the data frame. So I'm going to iterate across this array of column names, and then apply to that column name the simple version of splitter. You could also use a lambda function for this. It's really sort of the same, same amount of work to use a defined function instead. So this is how I'm going to test it. I realize here that I don't have my plot limit installed, and I can see that I've got basically what I wanted, except I've got line break characters. So I'm going to add to my splitter function. This is the beauty of doing it not as a lambda. Now it's obvious where I'm doing. So I'm just going to remove the new line character for each substring. Use that as a list comprehension, and the function remains nice and tidy on one line. So the next thing that I know that I'm going to need is a comparison function. Something that returns what are the something that mimics the red, green, and orange boxes that come up when you guess a champion in the LoLdle. So the way that's going to need to work is for each attribute, it's going to need to do some comparison on the two data frame fields. So I'm going to pass in X and Y being rows of a data frame. So those are technically pandas series objects, and I can access, sort of like a dictionary, I can access with X square bracket col for each col name the attribute, and so then I can use that to do the comparisons. So you can see here I'm setting up to have a couple of different conditions for this comparison. So in the case where column element is a string, that'll be for gender and for resource. We just want to do a direct comparison. So return true if they're equal, return false if they're not. So in fact, the line that it should come up with, Copilot's being overly obvious here, is return X square bracket col equals Y brackets col. Single line valuation is much neater. I like that. So here we can see getting into slightly more complex logic where we've got a comparison of lists to see if any elements are the same, if there's any overlap, there's an orange square. If they're exactly the same, so bottom middle with bottom middle, for example, then it'll return green. And if neither of those are true, then it must be the case that the intersection is the empty set, which means that we return red. And you can see here I'm using a lambda function in order to pass both X and an outside variable into the apply. So normally with apply, you can only supply a function name and it will pass rows sequentially as the argument, but you can use a lambda to get around that. A little hack for data framework here. So you can see here I'm looking now at the outputs of my comparison function, trying to print the resultant array, and I'm getting some errors. So back to ChatGPT, just prompt it with little questions like, what if the row is being passed to the series? How do I get the column index? And then I realized that I can't use the .isIn method with the list because that only works for NumPy arrays. And I realized, wait a second, hold on. What I can actually just do here is use sets. So sets are a fantastic built-in in Python, often really underutilized. What a set does is return all the unique elements of a collection, and there's sort of built-in functions for manipulating sets. So in sort of set theory terms, what I'm really after is the case where the intersection is non-empty, which is to say orange. The case where the intersection of the two sets is equal to both of the sets, which is set equality. So in fact I can just say if set x col equals set y col for that. I think I've done this in a stupid way. Oh sorry, no, that's what I've done. If set of x col and y col is equal to set of x col. And actually I've just realized that that's wrong, and I'll have to go back and correct that, because what I've got there is comparing if the intersection is equal to set of x, which will also return true if x is a proper subset of y, which is not the behavior we want. So I've now I've not now fixed that, so I'll be getting some incorrect results in my output. So you can see down the bottom, I've created this output array for every champ in the data frame against my randomly selected true one. I've decided here to standardize to red and green for all of the outputs. It makes no sense for that array to be a mix of strings and booleans, because I'll do everything else comparison on strings after this. So I've almost got a working comparison function. What I'm going to need to do now is test it. So I'm here firing up LoLdle so I can check that my outputs are correct by comparing them to what will happen on the actual LoLdle. So I already know that the underlying champion is Katarina. I'm here now realizing that when the comparison is of the release year, it actually doesn't return just red or green, it also returns up or down. So I'm now modifying if column contains an integer, the year, then we compare for exact quality and then for inequality. So after a couple little tweaks to the comparison function, I realized that I have essentially everything I need to create a perfect working replica of LoLdle. So I implement a while true game loop, take user input for a guess, use the comparison function to return the correctness of each attribute of the guess, print that to the terminal, and repeat until I find the correct champion. So that is until the comparison function returns 7 greens. And what you're seeing in the background is me literally playing LoLdle in my terminal. So at this point we've now spent about an hour and a half on this project so far. Implementing the game loop is obviously a little bit of a digression, not strictly necessary for our ultimate goal, but I found it was actually really quite a fun way to test, and I in fact did find some bugs in my comparison function, such as the set subset problem that I mentioned before. So all in all, it actually turned out to be quite a helpful way to debug. So anyway, I implemented this, solved the LoLdle, took me way too many tries, and now we're ready to set up the main event. So the basic principle is that we want to try for every champion as your starter guess, and every champion as the correct answer. So 160 times 161 combinations of the game. That number works out to be about 26,000. So that's initially what I'm coding up here. So increment I over the range of the length of the champions, set that as your starter guess, and then we'll go to an outer loop on that, which will iterate over all of the true champions, the correct answers, and that's going to be our first approach. So we'll implement a counter for how many guesses the solver takes for each combination of starter and correct answer, and we'll add that to a dictionary with every champion's name in it, and then we simply look at the end, the champions that took the most guesses, starter champions that took the most guesses in total, have got to be the worst ones, converse, for the best ones. So the last big design thing we have to sort out is the algorithm that's going to actually make the guesses for us. So I'm going to demonstrate in a sort of interactive Python session here in a second how exactly I've set that up. But the gist of it is to do with comparing the information we gain from the guess with the information in the rest of the data set in what I think is a reasonably clever way to do this very simply, rather than having to spend ages writing up rules for how the guesser should make its guesses, I suppose. So now we've got our 3 champions. To illustrate this example, we have Bard, Belveth, and Blitzcrank. So what I'm saying here is that Belveth is like the true answer, and I'm guessing Blitzcrank. This is what I'll return. Red, not the same gender, not the same position, not the same species, not the same resource type, same ranged, I think, because they're both melee, different regions, and Belveth was released more recently than Blitzcrank, so the arrow points up. So we have this much information about Blitz. So now all we need to do to figure out what we should guess is run the comparison algorithm for Blitz against every other champion in the database. And this is all like information that we're allowed to have, because you're allowed to know all the attributes of the league champs. It's not giving you any unfair advantage. So all we have to do is comparison Blitz with Bard, say, and notice that this, okay, so the first two indices are red, that's +1, but this doesn't. This is +1, nothing, nothing, +1, +1. So this is a similarity of like 4 out of 7. So that's what we're doing in this df copy score line here. So the more attributes where the comparison matches, the more likely it is to be correct. And in a lot of cases, there's more than one champion that can exactly match, but only the correct answer is guaranteed to exactly match. So you'll get at least one entry in the data frame with a score of 7. So the way the guessing algorithm works is simply that we pick the element of the data frame with the highest score, which a lot of the time is going to be the correct answer, so we get it in 2. In fact, what I'm actually looking at is the wrong document here. So we create a comparison score for every possible guess. We pick the one with the highest points. Simple. I did this, and initially I got some very surprising and quite obviously incorrect results, which I'll show the Excel sheet for in a second. Okay, so now I've run my program. I let it run for 20 minutes while I had dinner, so effectively 0 development time. And I've opened it up in Excel to look at the data set, and immediately I noticed that I've got 0 guesses against Kiana, which is a very silly mistake to make. But basically I indexed my for loop wrong and I didn't use Kiana as a starter ever. And then I'm looking at the results and I'm seeming like, okay, yeah, these make about sense. These are like a touch over 2 guesses per game on average, so it looks like the solver algorithms worked. But just want to make sure I've got the correct interpretation of the results here. So you'll see me sort of looking through the list, messing around with the data, and in a moment here I'm going to start making some charts, and I'll point out what I learned from these charts, which is actually quite important. So here I've got a histogram and a sorted scatter plot, so I'm trying to get a sense of the shape of the distribution, and this seems sort of like I would expect. Like the long tail will be from champions who give very little information on their first guess. Perhaps they have a lot of shared characteristics with a lot of champs. But more importantly, what I'm about to pick up here is that when I draw a scatter plot of the data frame index and the number of guesses, that shape is not right. So that's what statisticians would call heteroscedastic. So the variance is a lot bigger at one end. There also seems to be a little bit of a slope. So, you know, there's absolutely no reason that the order of the champs in the data frame should be affecting the distribution of total guesses, but something has happened. And what I figured out eventually was that in the case where there's a bunch of champions tied with the same score, the algorithm will just go through them one by one. So it will always guess the lowest ranked in the data frame, which is only ordered by the way that I manually enter them into the web scraping tool. So completely not correlated to any real variable. So there, just the simple task of drawing up what the data looks like in Excel actually pointed out like a very foundational mistake that I'd made, and I was able to go back and correct it. ultimately, I fixed all the errors with game logic, set it up to run, I believe, 50 times through all 160 x 161 combinations of starter and correct answer champion, tally up all the guesses, sort the result, and look at that. Talon is the best starter guess, and I think that makes sense. He's released in 2011, which is, you know, right about halfway through the champs. His characteristics are like clearly well defined. I figured that the orange ones are the least useful for this because if it's orange, there's more possibilities for what it could be intersecting with. So Talon has a lot of single characteristics. But that said, the difference between the numbers in the top sort of 5 or 10 is pretty minimal, so I can believe there's an element of randomness now because I made it so that the guesser picks a random selection if there are more than one tied for the top score, and I do that by shuffling the data frame each iteration of the guessing game. But anyway, I would say that all of these lists, and these are all champions that were released in 2011 or 2012, which suggests that there's a real correlation. And just to prove a point that the previous error has been fixed, here's what this scatter plot should look like, which is perfectly uniform randomness across the range over a sort of interval of about 5,000 total guesses, which is the difference between a 2.5 average and a 3.3 average. Belveth is absolutely the worst. Another thing I got sort of compelling suggestion that my results are accurate is that I ran a similar version of the same code, but using a sort of heuristic for guessing such that it would get it wrong a lot more of the time because it wouldn't have perfect knowledge of the game. So basically mimicking human behavior. The way that works is basically the same to tally up the comparison strength between your starter guess and every other champ in the database, but then to probabilistically pick from the higher end of the spectrum, weighted by the score, but such that it would grow because the score accumulates over multiple guesses. So the correct champion score in the database keeps climbing higher and higher. So eventually your probability is basically 1 that you'll pick it. So what I'm going to do is check the sort of correlation of the two data sets. So if they're agreeing, if the order is sort of roughly similar, then that suggests that we're onto something, that we're seeing real results, not just the result of randomness. So the way I'm going to do that is by matching the elements of the first array, the robot solver, against the elements of the human array, the ordering. So I'll just drag that down. So the first thing that we can do is check how this correlates to just the simple row number. Of this array. So we should see very strong correlation here. Then we pop in that scatter plot and look at that, that's beautiful. So that's saying that, you know, there's a very, very high degree of correlation, which means that we're seeing real results. You wouldn't see this if they were random. Another sort of measure of the spread we can do is take the absolute value of the difference between the row positions. So we do that over the whole data set. This somehow comes to an NA, right, because I messed up with Kiana on my first data set. Let's just delete that, forget about it. The average is 7, so the average, 7 is pretty low, given that it would be sort of 80 if this was the result of pure randomness. That might not be true, it could be 40. Either way, my made up heuristic is telling me that I've done a good enough job, so I'm going to say that, this is my list. Interestingly, Varus, which was what was recommended by that guide that I talked about way back earlier in the video, makes the top 6, so potentially they were onto something with the reasoning that they gave. So, conclusions. Was this a worthwhile project? Yeah, I mean, I think this was an interesting result to have obtained. This took me probably 3 hours of actual work time. So from sitting down, starting the project, opening up VS Code for the first time, to hitting run on the final version of the simulation, was about 2.5 to 3 hours of work. And that's something that I think, that's a pretty quick turnaround. I'm pretty pleased with that. I feel like I'm happy with where I'm at as a coder. I've been coding for about 2 or 3 years now, and I feel like I'm starting to feel like I have an idea of what I'm doing some of the time. This is a new sort of video. I haven't done anything like this before, so apologies if it's a bit janky and incoherent and the editing sucks and all of that. I did a lot of this sort of just from the top of my head, like I didn't sit down and write a script or anything because I just can't be bothered. But if you guys, if people actually do like this and would like a sort of coding with Crab series, or maybe some more structured tutorial, like explaining specific functions or how I do things, then I'd be keen to make some of these. I kind of want to become a productivity influencer. So anyway, that's it. Leave a like if you enjoyed this video. Subscribe to me if you feel like it. If this gets more than 50 views, I'll be fucking stoked, because honestly, I don't think anyone cares. But peace out.